Part E, a population of summer squash plants produced only green and yellow fruit. The percentage of plants producing yellow fruit in this population was 36%. Use the Hardy-Weinberg equation to calculate the percentage of plants that were heterozygous for gene B. So the information that they give us in the question is that the yellow fruit plants were 36%. So if we have a look back at our diagram, we can see that we're only looking at gene B, but in order for them to be yellow, they only require one of the dominant alleles. So therefore, those individuals that are yellow, we don't know if they are heterozygous or homozygous for that particular allele. But what we do know is that those that are going to be homozygous for the recessive allele will be the green individuals. So we can work out who is homozygous recessive. So we look at our information. If 36% were yellow, then we would do 100 minus 36%, which would give us 64%. So we can be certain that 64% of those individuals were green, and those 64% were homozygous for the recessive. So in terms of our Hardy-Weinberg equation, they are Q squared. So if Q squared equals 0.64, because we would do 64 divided by 100 if we were given a percentage in order to make it into a frequency. So we have 0.64 as Q squared. We would square root this to get 0.8. We know that P plus Q equals 1. So if Q equals 0.8, then we would do 1 minus 0.8, which would give us 0.2. So therefore P would equal 0.2. In terms of Hardy-Weinberg equation questions, if they don't give you the equation, it is always worth writing it down. Sometimes you can get a mark just for writing the equation, which is P squared plus 2PQ plus Q squared equals 1. In terms of this question, we are trying to identify the heterozygous for gene B. So the part of the equation we're looking at is the 2PQ. So again, it's always worth trying to state which part of the equation you are trying to work out, because sometimes that can gain you a mark even if you calculate it incorrectly. So in this situation, we're looking at our 2PQ for our heterozygous. So therefore we would do 2 times by 0.2 times by 0.8 equaling 0.32. We would times that by 100 to give us the 32%. So in terms of our equation, the correct answer of 32% gets you 2 marks, but even if you've got the incorrect answer, but you've identified that you were looking for 2PQ because that was the heterozygous part of the equation, then you can still gain 1 mark. So it is worth putting out all of your complete working so that you may gain some marks even if you get the end calculation incorrect.